Hi, welcome to week 5, lessons 1 and 2 video. So the algebraic simplification worksheet, which is this one, pretty simple. First, any of these, you find the common denominator. The first common denominator is going to be 70. So you're going to have 105 plus 50 minus 64. So I mean, that's how that one's going to come out. This, multiply this side by x plus 2, add them together. So you'd have 2x plus 4 plus 2x, so 4x plus 4 all over x squared plus 2x. Similar thing with this one. Factoring, this one's simple. It's going to be x minus 5 times x plus 2. I just factored this out, knew that I had a difference between 5 and 2 for 3. Since it's a negative here, I knew that my larger of the two numbers needed to be negative, and that gave me that answer. This is going to be y times x times x minus 2 times x minus 2, giving you this. And then this one, a little bit easier. It's going to be 3x minus 1 times, or plus 1 times 3x minus 2. And that will give you that one. This can be simplified because the x squared minus 1 can actually be extracted to be x minus 1 times x plus 1, meaning this simplifies to x plus 1, because the x minus 1 and the x plus 1 would cancel. The x minus 1s would cancel out, leaving you only with the x plus 1. And then this one you can take, it's going to be x times x plus 2, because again you can extrapolate this. 4 minus x squared is going to be, actually, hold on, gotta think through this one really quick. I lost my notes, so bear with me. So we're going to leave that x alone. We're going to focus on this. And so you're going to have a negative x and a positive x. So it's going to be 2, yeah. So you're going to have 2 plus x times 2 minus x. And so the 2 minus x, so it's x times 2 plus x is the answer on that one. Simplifying this, you'd go ahead and you'd multiply through. So x squared minus 2x plus 2x minus 4, so it's x squared over x, which means it's x, because each of the x's would cancel out. 2x squared minus x squared, I can take an x squared out of both sides, or out of both of these, which would cancel out, so I'd have 2x squared minus 1 is the end answer on that one. And since I'm not factoring, I won't go any further on that. So that's that portion. So extension problems. This one's fairly simple because all you have to do is start plugging in angles. And so I picked an angle directly on the y-axis. I picked pi halves. And it does not equal the same thing. So because 2 times pi halves gives you pi, which moves you down to 0, where 2 times the sine of pi halves would give me 1 times 2, which gives me 2. So there's an easy one. Then go ahead and let's work through these other ones here. So find an equivalent algebraic expression for sine times tan inverse of x. So we know that the tan inverse of x is going to be the theta, because x is going to be a side. We're going to get, so this is sine of theta. That's an equivalent algebraic expression for that. So yeah, we're looking for the sine of theta. So, and that also answers that, because we know that when we're taking the inverse and we know this is a side, we know it's going to return an angle for us. So if we had, our upright, our bottom, and our hypotenuse, we draw our right angle, which is 90 degrees. So based off of that, we have our other angles, and then so we'd have, you know, the height, the length, and the hypotenuse, which would work into our SOHCAHTOA, our opposites, adjacents, and so forth. So moving on really quick. I'm just trying to get through this. I have some stuff to get done as my wife is having problems with the pregnancy. So forgive me if I miss going over stuff as I'm going through. This, you work out, and it ends up being sine x plus cosine x times sine x minus cosine x. All that has to do with the a squared plus b squared algebraic equation and how it breaks out. This one is tan x. Since you have a tangent, so I mean it's actually tangent alpha, because sorry, they have an alpha. Took the x from here and put it down. So pull the tangent out, leaving you with cosine squared minus 2 cosine minus 3. And then we just factor it. I mean, pretend that the cosines are x's, and you can factor it out to cosine x minus 3 times cosine x plus 1 times tangent, again with the x, sorry, alpha. So it'd be tangent alpha times cosine alpha minus 3 times cosine alpha plus 1, giving you your factored trigonomic expressions, pulling all the pieces out. So use the identities. This one is really interesting, because you can take I mean, you just work through things. So you work through your sorry, I'm having issues thinking through things. So you just utilize your identities, which we have here, and find the ones that match up, and eventually it does actually work out. Oops. As you go through, this equation is equivalent to this equation. A lot of that can be done because one of the things that you can do is you can actually split this into separate fractions, and we know that sine squared over cosine squared is the same as tangent squared. So now I just need to find out if, this cancels each other out. With cosine underneath, go back to our identities, and again, you just look for patterns, things that match things that are in there, or that you can get to give you what you need. And so it does work out in our favor. This one's a little bit easier because cotangent is cosine over sine. So this is cosine, and then secant is 1 over cosine. So minus is one of those. So the two cosines left equal out. Bam, done, easy. This one, we go ahead and we go back to our identities, and we discover that wow, totally blanking. I thought there was an identity dealing with cosecant and secant underneath. With the pluses and minuses. Again, I don't remember where my notes went. But yeah, it takes some time. You work through it, and it actually does equal out to 2 tan squared x. And a lot of it has to deal with making sure getting these common denominators and then moving forward. Because with common denominator here and here, you actually end up with cosecant squared x minus 1 on the bottom. And then you can play with your identities a little bit. So yeah, and that's it for this video. Sorry that it was not as thorough as I normally do, but yeah, not having the best night. So.